Hello and welcome to yet another video at Codamy. Last time what we did was implementation of hash map. We did two videos. First we did just simply implemented the hash map. The second one we saw what separate chaining is, and we did implemented it with linked lists. Today what we are doing is merge sort. This is an algorithm that for sorting arrays, and it is used widely uh, in several you can find several examples, but so what it does is it takes an array and it divides that array into it recursively divides that array into two parts of roughly the same size, and until there is the size of the all the arrays is 1, and then it starts merging them back, and when it merges the arrays, it takes into account which should come first and which should go later, and that way we have a sorted array in the end. So if you want to read more about the algorithm itself, you can do that on several resources. What we are going to do is implement that in Java. So what I have at the moment is just an array of size 10, and I'm just giving that random arrays, that array random integers from 0 to 50, and then sorting them using bubble sort. Bubble sort, as we all know, is the simplest sort there is, but its complexity is very high. That is n square time complexity. What it does is just checks all the elements and then just like swaps the elements that should be swapped. I'm not going to explain that here. You can read about that further. So what we are going to do is implement the merge sort. So by looking at this picture, what I can gather is we have to have two functions, right? What the first function will do, it will take an array as an input and divide that array into two different parts of roughly the same size. And they don't have to be the same size, but roughly the same size means if the array contains an odd number of integers, then it should be like 4, 3, 5 or 6, like that. Otherwise that they will be evenly divided. So the first one will be, I'll call that merge sort, and it will return an array merge sort, and it will take an array as an input, right? And let's say it returns an array at the end, right? Now this is like temporary. So to start with, we have an array and we have to divide it into two different parts. So first off, we should have some variable that has the size of this array, right? So we'll say int size will be arr dot length, and then we will have to have two different arrays. We'll call them left, which will be the size of which will be the half the size of what we have as an input array, or I can say mid is equal to size divided by 2, and I can then just call this mid, and we will have a right array. But for the right array, I'll have to first check whether the input array had odd number of integers or even number of integers. So if I'll say the array, or you can say size modulus divided by modulus of 2 is equal to 0, that means the number of integers in array is even. So we can have right as new and same of the same size as our left array. But in case of odd integers, we will say that right will be one integer bigger than the left array, right? So this will divide this will give us two arrays, but at the moment they both are empty. So what we need to do is we will have to put the elements of that input array into our newly created arrays. Int I equal to 0, I less than size I plus plus, right? And after that we can say if I is less than mid, we will just say left I is equal to ARR I. Else we will say right mid plus I equal to ARR I. So this should give us this should put all the elements of our input array into our arrays left and right. I think this should be it, and I think I I wrote this wrong. It should be I minus mid, because when for example if our array input is of 10 size, so our size this mid will be 5, and when it reaches 5 we should start putting elements into our right array, and the index of that should be 0. So at that moment it will be 5 and the mid is 5, so it will be 5 minus 5 0, and this will still be 5, so we'll have right 0 equal to ARR 5, and like that. Okay, and at this moment we can say that we have divided this array into two different parts and put all the elements into these arrays, but we have to recursively call it until we find the we reach a point when the size of the array is 1. So let's write that base case here. If size is equal to 1, we'll say return this array that we received as input here, and otherwise what after doing all of this we'll say just call the same thing on this array, right, and call the same thing on right array. So we know that it will return the same size of array that we have provided it as an input, so we can just simply call this call it like this. So it will recursively call it itself until it has divided our input array into one element, right? So that's I think it for the first part of this algorithm. The next part is to write a function that will merge these arrays in a fashion that we get a new array which is sorted, right? So let's write another function which I'll call merge. It will also return an array, but it will take two arrays as input. First one will be left and the second one will be right. So first off, to start with, let's have so what do we know? We have to return a merged array. We can say merged array which will be the size of these two arrays. Adding if I add the size of these two arrays, I'll get the merged array size, right? So we'll just say new int, and the size will be left dot length plus right dot length. So this should be our new array, and I have to add these brackets here. So this will be the size of our new array, right? And now what do we have? We will have three things here. Int first will be merged index, the second will be left index, and the third will be right index. And I'll initialize this as 0, and let's go ahead. So what do we need to do now? I have to look at left and right and see which element of this array should which first element of from these two arrays should come first inside the merged array. How do we do that? Let's say we have left index starting at 0 and right index starting at 0, and we will go until how do we say that? We can say until we have two things: until left index is less than left dot length, or sorry, not or, and right index is less than right dot length. So what this means is until one of the arrays is empty, we will keep going will keep looping through the through both of those arrays, right? So I need to check whether which one is the smaller integer in both in these arrays, right? I'll say if left at left index is less than right at right index, if the element that I have in left at 0 index is less than the element that I have in right at 0 index, I'll say merge array merge index will be left at that index, right? And otherwise, and I'll have to here do to increment these indices like this. So I can do it like this, or I can just go here and add the increment operator here. This will do the same thing. So if this is the case, do this. Otherwise, add the right, add the integer from the right array, right? So what it is doing is, for example, I have these two arrays, right? So first I am checking the 0th index, which is for left is 27 and for right is 3. So first off, I will check which of the 27 and 3 is a smaller number. So 3 is smaller, so first I put 3. Then I check and I increment this index, which is now it points to 43. And now I check 27 and 43, which one is smaller? 27 is smaller, and I put that in. And I increment this right and left index, and it points to 38. I check whether 38 is small or 38 is smaller or 43 is smaller. So 38 is smaller, I put 38 in, and when this is empty, I will be coming out of that loop. And to put 43 in, we will have to write some more code. So here, so at this moment, when we come out of this array, we are sure that either one of the two arrays is now empty. So we can check if we can say if left index is equal to left dot length. If this is the case, that means left is now empty. So what we can then do is we can then loop through the right array and put everything that is left in the right array into our merge array. Right index is less than right dot length, right? And we'll just say merge array right index plus plus equal to right at right index plus plus. So if left index if the left array is emptied first, we'll go through the right array and put everything that is left in the right array to our merge array. And if that is not the case, if right array is empty, so what we will do is we will go through the left array, left index is less than left, and put everything that is left in our left array into our merge array. And in the end, when we have done all of that, we'll just return our merged array, right? So this is what we are going to do in our merge function. And here, what do we need to do here? We will call the merge. We'll just say return merge left and right. So I think this should be it for to start to merge to sort the array that we provided. Let's go ahead and test it. So let's run it. Okay, so there is something merge 42. Okay, so this should not be right index. This should be merge index. That's merge index. I'm sorry, that was wrong. Let's run it again. Okay, so it's working. So we have an unsorted array which is 19, 30, 7, 49, whatever, and then we have an output which is 0, 7, 15, 19, 20, and this and that. So this way we can this is the implementation, the very simple implementation of merge sort that you can use for your own self also. So I think that is that. I hope you enjoyed this short little video, and thank you for watching. Goodbye until next time.